Alright, I wanted you to see, I'm starting to sort of fall off the bottom of the page earlier. So I finished this division of the one factor into my original problem, and I have this trinomial left. And so I'm going to take my other factor and divide it into this trinomial, and that way I will have factored out both factors from my original. So I've started to do that here. And I took the trinomial and added a 0x to it because I needed an x to the third, an x to the second, an x to the first, and an x to the 0th to really do this properly. I'm going to put an x squared up here, and x squared times 2x is going to give me the 2x to the third that I was looking for. X squared times 1 is x squared. Subtracting that, and I'm going to get negative 8x squared, and I'm going to bring down my 0 to the x. Now I'm going to divide 2x into negative 8x squared, and I'm going to get a negative 4x. So when I multiply that together, I'm going to get a negative 8x squared minus 4x, and again I'm subtracting that. So 0x minus a negative or plus a 4x is going to be plus a 4x, and negative 8x minus a negative or plus 8x cancels each other out. I'm going to bring down my 2 because that's x to the 0. I don't really need to say x to the 0. Multiply it by 2, and 2 times 2x is going to be 4x. 2 times 1 is 2. Subtracting it, they completely cancel each other out. I have 0 remainder. So basically we know now that if I take my first factor, which was x minus 1, times my second factor, which is 2x plus 1, times x squared minus 4x plus 2, I'm going to get my original polynomial, which was set to equal 0. So I do still need to factor this. Let me get that out of the way. Maybe I'll make it very small. Okay, so this is my A, my B, and my C. So I'm looking at this thinking, well, something times something is going to equal 2, and that same something plus something is going to equal negative 4, right? Wrong. I can't think of anything that's going to work there. I'm a little stumped, and I think I'm going to have to turn to the quadratic formula to figure out my additional roots. I mean, I know I have a root of 1, I have a root of negative 1/2, but since my original problem was to the 4th, I know I need 4 x values. So hopefully the quadratic formula will help me figure this out. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In case you've forgotten, it's a great thing to have on a note card. So here is my a, my b, and my c. So I can say that x equals negative 4, that's my b, plus or minus the square root of, let's see, negative 4 is my b squared minus 4 times 1 times 2. This is not this 4. This is just part of the quadratic, well, it is this 4, but it's not this 4. It's part of the quadratic equation. 2 times, and my a is 1. Right? So if I crunch that, I'm going to end up with oops, I didn't need quite all that. which equals 4 plus 2 root, oh, that was all over 2. And then I also have the 4 minus equals, keep it straight. So in addition to having an x equaling 1 from the last video and an x equaling negative 1/2, I now also have x equaling 2 plus root 2 and x equaling 2 minus root 2. And I believe we're done. Oh, multiplicity. We don't have any, we only have singles here. We did not have any of these more than once. So we have a multiplicity of 1.